Okay, students, let's take a look at this bonus problem here, or bonus question. Many of you might have struggled with this, I imagine, because it's a little bit different. Clearly, it's going to be a playoff of two different things here. We're going to invest $20,000 here, and that is our upfront cost. There's no present value calculation to make, because that happens in year zero. What we're getting, oops, what was that? What we're getting here is we're going to get the benefit of $4,500 every year for 8 years. And I would draw them all out, but to save time, I'm just going to show 4 of them. So this means a break in time here. This is year 1, year 2, year 7, and year 8. I just skipped a whole bunch of them to save time on drawing. Okay, so $4,500 a year is what we're going to get here. And this is obviously the playoff of two different things. It's going to be an annuity here that is $4,500 a year for 8 years, and you're going to offset that with this upfront payment of $20,000. Now there's no present value because we make that payment today. So let's go back to the annuity. First of all, we would start with this present value of an annuity, right? And let's figure out what that is. It's going to be $4,500. What's going on here? I don't like the way that looks. Okay, we're going to go present value of an annuity equals $4,500 every year for a certain number of years. It's going to be 8 years. And the missing thing here that might throw people is we don't know what that interest rate is. I'm just going to put a question mark there. Okay, so what's going on here is that we don't know for sure how to go find this factor. Okay, this computer's having problems for me right now. What we do know is this, is that there are a couple things in play here. Okay, and so we've got this 20K over here, which I think I've indicated in red. So this is an investment right up front. So here's where you have to kind of think about it a little bit. Okay, so if I'm going to be getting all this green part over here over the course of years, then it's got to be equal to the red part. So what's going to happen here, people, is I'm going to say that this $20,000 investment up front is what the value must be, because that's what I paid for it. Now that's equal to the 4,500 here times some factor that I don't know. In fact, I'm just going to write this as an unknown factor. Boy, my computer's having some problems here today. So that's my unknown. So now what we have to do here to find this factor, this is what we're looking for. Normally we're just kicking out a dollar amount. But what we do here is now you're going to say $20,000. I won't abbreviate anymore. I'll divide by 4,500, and it just becomes an algebra problem. So this is what I'm looking for. I'm trying to find the factor, because a factor is going to be a percentage rate, an interest rate. Man, really having some computer issues here today. But anyway, we're going to try to find that percentage rate and figure out what that is. So just like in an old algebra class where you went 6 divided by 3 equals x, and then x was 2, now we've done the math here. And if I just say 20,000 divided by 4,500, if I do the math there, I get a number here of 4.444. In fact, I think it's 4 repeating. So that must equal my factor. Well, I do know if I go to the table here and I look for some row where I know n equals 8, because it's 8 payments, I can find the interest rate at which that makes this a true statement. Okay, so that's what I'm doing. Now, yours is more detailed, but if I go to this interest rate factor here, notice I had to go to the right one, present value of $1 per year for each of t years. Okay, I know I'm looking at row 8. Okay, I'm looking for where 4.44 occurs. Okay, and look, it goes off the chart. I get 4.4 way out here at 15%, but it goes all the way off the chart. So it's probably between 15 and 16%. That's what I've learned from this. Okay, so really, when I say what's the return on investment, it's got to be about 16%. Just take a guess at it. Okay, so again, one of the issues here with these, not one of the issues, but one of the valuable pieces is that we're so obsessed in accounting sometimes to find an exact numerical answer to the dollar. In fact, I've given you exact dollar amounts as answers on this worksheet for every problem except this one. But really what you want to understand is that the answer to the exact dollar or to the exact cents is not nearly as important as understanding the concept. If I've paid $20,000 up front here, that's the present value here. If I'm going to get all this stuff later on over time, then those have to be equal. And all I have to do was divide those two to get my factor and then go look for the factor in the table like I just showed you here. Okay, so when I found that 4.4444 was even beyond 15%, I could probably say with good confidence it's between 15 and 16%. And when you're looking at an investment, who cares? Do you really care if it's 15.7 or 15.55 or 15.92? All I know is that's pretty good. Okay, if I can go make 16% or 15% plus, that's pretty good. That's enough to make a good informed decision on. Because as you guys have probably discovered, the interest rates do change. This is not a perfect process. It's a model. And as one of my favorite professors used to say, all models are wrong. They're just models. Some models are useful. This net present value calculation is a useful model to make informed decisions about business and finance. So I hope you find that useful. Okay, there you go.